Hi boys and girls, it's me Butch. My name is Terry David Silvercloud. I'm not native, just sounds that way. I'm 81 years old. Today is the 27th of December, 2025. It's 5 to 3. I'm just testing out gear, so I'm going to make a short video where I'm going to talk, I think, about the Electron. Butchie Poo has had an interest in electrons since he was about 12 to 14 years old, somewhere, about 70 years ago, when he taught himself how vacuum tubes and transistors and radios and TV sets work. He just had to figure out, like, how do these things work? So he got a book out of the high school library and he taught himself. Excuse me, I have to clear my throat. Smoking too much pot. All right, all you camera guys, you still tracking me? So, I've taught myself a lot about the electron since then, and since I'm into physics, I have a lot of my own ideas. So some of the things I'm going to talk to you about, you're not going to find in any physics books. If you don't believe me, well, try to prove me wrong. I know what I'm talking about, and this is not new stuff to me. I just realized that one of my cameras up there cuts my head off. I'll sit down for a minute. Give me another moment here. So now the problem in modern physics and electronics is that quantum physics has problems with relativity when things get big. Particle physics has some issues with quantum physics, and what I'm going to talk about fixes all those things, because these are my ideas I'm going to throw at you here. And you can believe them or not, it doesn't matter. In particle physics, the electron is a particle. It's one of the three major components of an atom. It's the smallest one, but it's one of the most important. And it governs our life completely. Everything you're just watching me, you're using zillions of electrons per second going through your smartphone or your computer or whatever it's going through, and your lights and everything. Electrons are everywhere. So we treat them as particles and part of an atom. They're extremely small, and by their physical size, this is kind of dicey, but close enough. They're considered to be 1/1836 as big as a proton or a neutron. It's very tiny. But we consider them to be a particle. Now, in quantum physics, an electron is a kind of a standing wave, and standing waves can behave like particles. If you get hit by a tidal wave, that's not really a standing wave, but it's one of the standing wave cousins, close enough as an illustration. You get wiped out by a tsunami. I just saw my neighbor driving away there. So it's a particle, and by being a particle, in quantum physics, it's not anything until it acquires some energy. But electrons are what we use to transfer what we call electrical energy through wires. Electrons themselves don't actually travel at the speed of light. Butch says, and you're not really going to find this in a book because they're not quite sure, but Butch is telling you because it's so logical. The electron sets the speed of light. The electron is the speed of light. Its diameter from here to there is the speed of light, but oops, there's something else going on. And what else is going on is when something is just an object out in nowheresville, space we'll call it, vacuum, whatever suits you, let's not get fussy here, it can spin right or it can spin left. And that gives a concept of up or down or forwards or backwards. there is no up or down, and there is no forwards or backwards. It's when you start doing that, it's because you're viewing something from your point of view, and that gets into something called relativity, and that screws everything up a lot of the time because it's so confusing. So everything is in motion all at once, all of the time, and the electron, of course, is spinning, and if it needs to absorb more energy, all it has to do is spin faster and faster and faster and faster. And there's a certain point when it starts spinning up at around 100,000 times per second, actually before that, but you'll definitely notice it up around then, it starts causing what are called electromagnetic waves or radio waves. And radio waves come in lots of different fashion. Frequencies and wavelengths are related. I don't want to get too diverted because I have ADHD and I just wander all over the place yakking about stuff. The whole point of this is to talk about the here-ness and the there-ness and the topness and the bottomness of the electron. And it has mass. We can measure it. And in quantum physics, when it's just sitting there, we say, well, it weighs the Planck constant. We have to throw that into our equations, which I don't have time to explain here. But it does have somethingness even when it's not moving. It's just that when it starts moving, to do anything, it is, when it's doing nothing, a quantum of energy just sitting there. But to do something else, it needs another quantum added to it. And within an atom, to get to a higher energy level within the atom, it has to make what is called a quantum leap. That occurs at the speed of light. But electrons don't go at the speed of light, you said. No, they don't go at the speed of light. They are the speed of light. What happens is, let's make a north-south here. Here's a nice hole. Is there a hole? Oh, cool, there's a hole here. Can you see the hole? There's a hole there. That's going to be our north. There is no up or down, but because I'm standing up, we're going to call this up and north. So the electron is spinning, and the reason it's spinning is something beside it is rubbing against it. It could be physical or electromagnetic. It doesn't matter in this case because it's behaving like a magnet. So if it gets near a magnet, the magnet's going to affect how it spins and where it spins even. So it is a spinning magnet. It's affected by magnetic forces. It's somewhat affected by gravitational forces. The point is there's more than just a spin going on, but as voltage increases, the electron spins faster and faster and faster and faster. It ain't going nowhere, and it's passing that information on at the speed of light, and it's still not going anywhere. It's just spinning because there's an electron, another electron right nearby. Oops. Here, we got a couple of electrons here. We'll have a right spinning electron and a left spinning electron. And remember, they can spin right or they can spin left. So here's one of each. The black one is a left spinning right electron, and this is a right spinning electron. And they have the same value, but they have different poles. What they think is up and down is different. And they could technically put their feet together and spin together, and they'd be perfectly happy doing that. But they don't really like doing that, except in the structure of atoms. Getting back, oh, now I've totally confused you right here. What the hell is he talking about? Okay, what are you talking about? So how does the energy get from here to there? So this might be an easier way to show you. This black ball is energy trying to get from there to there. It's trying to get from there to there, but the damn electron is in the way. But if it spins fast enough while it's rubbing, it'll cause the electron to spin rubbing against it. And then if there's another one of these little suckers over here, we're going to say pretend they're all electron. They don't have to be touching exactly because remember they're magnets, and magnets even at a distance can spin other magnets. So as it's spinning, it's causing this one to spin, and when it does a half turn from there to there, it has transmitted the half spin of this electron to over here. It hasn't gone anywhere, but it has transmitted energy from here to there. Okay, so that's basically how electrons do their job. Another way they can do it is when they get all excited, you can cause them to wobble and vibrate, and we do, and mostly that happens with what we call alternating current. So the electron doesn't really have to do anything. It just goes or up. All it has to do is wobble really, really fast. And for instance, if we can make it wobble 60 times a second back and forth, that's 60 cycle current. For you folks in India, 50 cycle current. So 50 times a second, the electron is jiggling back and forth. Again, with this, remember I told you if you can get the electron to spin faster than 100,000 times a second, if you can get the wobble to happen up in those ranges, you will also be transmitting radio waves. And we do that. That's sort of really how it's done, and I don't have time to get into that. But basically, we make the electrons inside a wire jiggle at 100,000 times a second, or very, very fast. And because they're doing that, the wire, which is sticking out somewhere, it's causing the electrons anywhere nearby to be affected by these electromagnetic waves they're sending out. Now, the waves are traveling at the speed of light. The electrons aren't going anywhere. Remember, no electrons are really going anywhere. The information is going at the speed of light. So that, because I don't want to go on forever and ever with this video, and am I keeping track here? I don't want to get off out of the camera. I gotta make sure I'm in the camera there. Okay, I'm in the camera with everybody. Good. Where am I going with this? Okay, Butch's big idea, which is different than you'll find in any books, is the electron. I told you it sets the speed of light. You're not going to find that in the book. It's true. You try and prove me wrong. It is. You'll if you don't realize it, you will eventually come to realize it. The spin or the wobble is the speed of light by the physical size of the electron. Oh, before I get on to that, that's what I have to tell you. So I told you it can either be its diameter, moving its diameter, but it can also transmit, it can transfer information by moving its diameter, or it can by rotating half or a whole spin. That difference in the way it can send the force it's trying to transmit is what causes the radio waves, the disturbances of the things around it. And those disturbances are happening at the speed of light because the physical size of the electrons are shaking, and it's causing the speed of light. But getting back to the electron, because I do want to shut up soon, what's the electron made of? We can't smash it, or if we can't see the results very well because we need electrons to see the electrons, and now it gets really tricky to see things smaller than the electron. And we're finding ways to do that by using interference patterns between mirrors. Like we compare a bunch of reflections to each other, and we make the reflections interfere with each other. And they're doing that because of the physical distances we place the mirrors between one another. We can start measuring really tiny measurements in extremely small waves, even as small as the electron, but diverse. So what Butchie says before he shuts up here is there are such a thing as tachyons. They're a theoretical particle. You can look them up, and that's what you'll find. They're a theoretical particle. Some say travel at the speed of light. Butch says they travel faster than light. Why? Because they're smaller than the electron, and they set their own speed of light. Their speed of light is their size, which is smaller than the electron. So you could put a bunch of tachyons inside of the electron, and indeed, what she says, that's what's happening, but they're tied up in knots. And I don't have time to get into that, but the folks that like string string theory will like it a lot. So how big are they? Well, they have to be. There has to be a bunch of them in here, and they set their own size. So if you know that the formula for the volume of a sphere is 4/3 pi r cubed, and this is an electron, if we take the radius of the electron as being the speed of light, which it partly is, we need actually the diameter, but that's not too critical right at this particular moment. I'm trying to get a concept into your mind. Then the speed for the tachyon relative to the speed of light being set by the electron, because we're going to compare them both by their formula. For the tachyon, its velocity for itself is 4/3 pi c, the speed of light. If you want to divide it in half, go ahead, doesn't matter, because that'll make you feel better about it. The nerds will get what I'm talking about. If you want to divide it in half, that's not important. The important part is getting your head around the idea of the 4/3 pi c, the radius of the electron, cubed, not squared, cubed, because they have to fill completely, all at once, at the same time, the volume of the electron, all at once, all the time. They're not outside it, they're always inside it, but to them, their reality is happening at a much higher velocity relative to the speed of light and time. Remember, the speed of light is related to time. If you lived on an electron, you would be so small that 1 second of human time would be an eternity to you if you were living on the surface of an electron. So the speed of light is related to time, and the speed of light, Butch is telling you, if you're not going to find anywhere else, prove me wrong, go ahead. You're not going to prove me wrong, because I'm right. The electron sets the speed of light, and with that, Butchie Poo has gotten across. Oh, and because of this 4/3 pi c cube thing, you have to come to realize eventually that gravity is not pulling, gravity is pushing. Everything is like, give me room, everything. The tachyons want their room. As small as they are everything. Anything that is not matter is a tachyon. And its reality to it, space, vacuum, and they're little magnets too, the little suckers. They have left and right spin as well. They are space, but their reality is happening at 4/3 pi c cubed. As Butch, I'm looking at this camera because that's the main. You're the main test camera over there. You guys are a backup camera here, and for more video, because I'm testing things out. I like likes because then you feed my ego, and I'm an artist, so I'm doing this because I'm an artist, and I was a photographer, and I'm a painter. I'm into physics. Subscribers come and go because people find I'm something they don't like, and they have not learned to agree to disagree. So since they can't agree with me, and perhaps they disagree with me, they just they unsubscribe. YouTube doesn't care about subscribers anymore, fortunately. But my subscriber base just keeps slowly, it goes up and it whittles, it's always heading upwards. So I don't worry about that. I'm 81. I'm doing this because I could drop dead at any time. I just want to be entertaining, educating, useful somehow. It gives me a chance to try and be, look at the gut there, eh? If I'd known I know then, I know now, I could have avoided that, but I do try and set an example by staying in shape and trying to be the kind of guy who's a leader, not a follower. I want to be the leader, not the follower, and set a good example for you all, for the young gay folks out there. It's all going to be okay. Don't be shy. If you act like you're in charge, people think you are. And you're going to have to realize that everybody's more worried about themselves than they are about you. You think they're all thinking about you, but they aren't. They're thinking about themselves. We're all that way. We're all vain. Butch is bold enough to admit it because he's so self-confident. He just doesn't give a shit. Seriously, he doesn't. You have to prove yourself to me. I'll listen to everything you say and may not agree with you, but I'll definitely listen to what you have to say. And you have to prove yourself to me. That's just the way it is. I'm old. What do I care? So I'm going to shut up. It's going to be bye-bye from Butch. I guess I have to shut cameras off now. So I'm just going to say bye-bye, and we'll just edit this all out at the end, okay? Bye-bye, everybody. Bye-bye.